At the heart of the G80 locking differential is a beveled gear set, similar to the one in an open differential. There are two pinion gears located on the cross shaft and two side gears splined to the axles. These gears are precision forged for high impact strength. One of the side gears has cam ramps machined on the back face. These ramps align with corresponding ramps on the cam plate. There are 4 protrusions, or detents, on the cam plate, which mate with 4 holes on the side gear. This prevents the cam plate from ramping until a predetermined force, or torque, is applied to the gear teeth. After the cam plate rotates out of the detents, the ramp surface on the cam plate engages the ramp surface on the side gear. As the cam rotates further, the ramps cause the cam plate to move in an axial or sideways direction. Because the ramps are symmetrical, the same action occurs in forward or reverse gear. Located behind the cam plate are an active disc pack and a wave spring that keeps the plate in the rest position. Following are more friction discs, along with guides and snap rings to help align the parts. On the opposite side of the differential, behind the other side gear, is another set of friction discs. The compressive force created by the cam gear develops torque in the first disc pack, which transfers through the center of the differential, through the side gear, into the second disc pack. Now the 2 rear axle shafts are locked together. The device that initially activates the cam plate is the engagement mechanism. It is connected to the cam plate by a small shaft, which attaches to the mechanism through cone clutches at each plate. The mechanism rotates when the torque between the shaft and the mechanism is greater than the cone clutch torque. The mechanism is made up of 2 flyweights that are spring-loaded toward the center of the shaft. The shaft rotates whenever there is a differential speed between the wheels. When the differential speed reaches 100 RPM, there is enough centrifugal force on the flyweight to overcome the centering spring. The flyweights move outward to engage the pawl of the lockout mechanism. One flyweight engages the pawl in one direction of rotation, the other flyweight engages in the opposite direction. If the vehicle is traveling more than 20 miles per hour, the centrifugal force acting on the counterweight of the lockout mechanism will cause the pawl to rotate away from the engagement mechanism, preventing the differential from locking up at higher speeds. With the parts back together, you can see how they work together to cause lockup. With one wheel spinning, the cam side gear rotates relative to the case. This causes the engagement mechanism to rotate at a higher speed. At a given speed, the flyweights will swing out and engage the pawl on the locking mechanism. This produces force on the cam plate, which rotates into the ramping position. The friction disc pack compresses, causing the cam to energize until sufficient torque locks the wheels together. With the wheels locked together, maximum driveline torque is available to the high traction wheel, which is why the Eaton G80 locking differential gets you moving and keeps you moving.
This diagnostic procedure tests whether the locking differential is functioning. With the transmission in neutral, raise the vehicle on a frame contact hoist so the rear wheels can rotate freely. Hold one wheel stationary. Then, slowly rotate the other wheel approximately half a revolution per second in both forward and reverse directions. The wheel should rotate freely. If the held wheel attempts to turn with the rotating wheel, the differential is locking and is defective. With an assistant in the vehicle, raise the hoist to its maximum height. Start the engine and ensure it is running at the lowest possible idle. Apply the service brake and shift the automatic transmission into drive. For a manual, depress the clutch and shift the transmission into first gear. Lock one wheel by pulling one parking brake cable from under the vehicle. Release the service brake or slowly release the clutch to start the free wheel turning. The locked wheel remains stationary. Gradually increase the engine speed. The differential will lock, causing either the rotating wheel to stop or both wheels to turn at the same speed. On a truck with a manual transmission, the engine may stall. In order to cause the differential to lock, it may be necessary to increase engine speed until approximately 10 miles per hour is indicated on the speedometer. If the differential still does not lock when the engine speed is raised beyond 20 miles per hour, the locking unit is not functioning properly. Lock the opposite wheel and repeat the process. To disassemble the Eaton locking differential, you'll need special tool J26252. After removing the side bearings, remove the governor bushing using the J26252. Remove the E-clips that hold the latching bracket on the differential pinion shaft, and move the latching bracket down the pinion shaft. Next, remove the latching bracket bushing again using the J26252. Then, remove the latching bracket shaft and spring, as well as the governor assembly from the case. Loosen and remove the lock screw from the pinion shaft if it is not already removed. Then, remove the pinion shaft from the case. Remove the differential pinion gears along with the pinion thrust washers. Remove the thrust block and the right side gear. Also, the right side clutch plates and the thrust washer. Remove the left side gear, the cam plate, and the clutch pack as an assembly. This is the cam unit. Remove the side gear thrust washer. To adjust the locking differential, you will partially assemble the unit and measure backlash on the pinion gears. The first step is to assemble the clutch packs for the left and right sides of the differential. Alternate the clutch plates in the pack. With the plates together, assemble the guide clips to the clutch packs using grease to hold the clips in place on the plates. Install the side gear thrust washer. Then, the clutch plate assembly and the right side gear in the case. To place the pinion gears and the thrust washers into the differential case, align each gear and washer with the pinion shaft hole and press down on the side gear to install the pinion shaft. If you cannot press the side gear down far enough to install the pinion shaft, use a thinner side gear thrust washer. Then install the lock screw. With the pinion shaft in position, rotate the pinion gear closest to the lock screw so that one of the teeth is pointing downward, perpendicular to the ring gear flange. Insert a large tapered tool, such as a screwdriver, firmly between the side gear and the pinion shaft. Mount a dial indicator gauge to the ring gear flange. Place the stem of the indicator on the tooth of the pinion gear closest to the lock screw and zero the indicator. Now, using the tool, pull the pinion gear firmly into the gear's seat and rotate the gear back and forth while reading the dial indicator. Record the reading on the dial. Gear backlash should be between 51 and 243 thousandths of a millimeter, or 2 and 10 thousandths of an inch. Use a thicker side gear thrust washer if the backlash is too high. Use a thinner washer if the backlash is too low. Repeat the backlash measurement on the opposite pinion gear. Place the stem of the indicator on the tooth of the pinion gear closest to the lock screw. Record the reading on the dial while you rotate the gear back and forth. Again, gear backlash should be between 51 and 243 thousandths of a millimeter, or 2 and 10 thousandths of an inch. Now, you're ready to reassemble the locking differential. This procedure is to adjust the clearance of the thrust block in the locking differential. Install the left side gear thrust washer in the differential case. Next, install the cam unit. This includes the cam side gear, the cam plate, and the clutch pack. Now, install the right side gear thrust washer along with the right side clutch pack. Install the pinion shaft and lock screw. Insert a pair of large tapered screwdriver blades firmly between each side gear and the pinion shaft to wedge the gears tightly against the sides of the case. Use a 1/2 inch telescoping gauge to measure the distance between the side gear faces. Do not measure from the gear teeth. Remove the gauge and take the measurement with a micrometer. Record the measurement. This is the total side gear spread. Now, use the micrometer to measure the original thrust block at the outer corner and record the result. For proper clearance, the thrust block thickness should be between 0 and 6/1000ths of an inch less than the side gear spread measurement. If the thrust block is not between 0 and 6/1000ths of an inch less than the side gear spread, adjust the clearance by either selecting a new thrust block or shimming the right and/or left clutch plates. Remember, backlash must be readjusted to specification after shimming. This is the assembly procedure for the locking differential. First, install the left side gear thrust washer in the differential case. Then install the cam unit assembly. With the right clutch plates and the guide clips installed on the right side gear, add the thrust washer and install the assembly in the differential case. Next, install the thrust block Then, place the pinion thrust washers and the pinion gears into the differential 180 degrees apart. Rotate the gears and the thrust block into position. The open side of the thrust block must face the small window opening. Install the pinion shaft. Now, install a new lock screw and tighten just finger tight. It is important that you do not tighten the new lock screw to specifications until after the differential assembly is installed in the vehicle. Install the governor assembly. Then, The latching bracket. It is important that the straight end of the latching bracket spring is over and outside the governor assembly shaft. Next, install the bushings for the governor assembly. If the bushings are different on the governor shaft, use the bushing with a straight hole, not the tapered bushing. Press the bushing in far enough to provide between 4 and 20/1000ths of an inch of shaft end play. Next, install the latching bracket bushing. Press this bushing in far enough to eliminate all of the end play.
Limited slip operation of the Getrag independent carrier assembly occurs when one wheel starts to slip. A gear separating force from the slipping side gear is applied to the rotating pinion gears, which is in turn applied to the opposite side gear, and the combined force pushes the side gears outward, locking the clutches and allowing both wheels to turn at the same speed.